Hello, this is Adam Morgan of AdamCodes716.com, also of IHateBadMovies.com. I review movies on the side. And the reason I bring that up is that if you're interested in AI, I did make a document on my website that shows how to make a movie recommender service using AI, so check that out if you feel so inclined. This is a second part series in the AI space. I previously did a video on smart assistants, OpenAI's smart assistants, assistant API, I should say. This one's going to be on Semantic Kernel. Now, who's this for? Semantic Kernel is fairly new. It's changing very, very quickly. Part of the reason I made this video is that when I started to learn this a few months ago, there's a lot of, I don't want to say misinformation, but it's changing so fast. The SDK is changing so fast. That it was hard to find good examples. It was hard to cut through all the data that's out there. So I'm trying to, if you're somebody that's looking to get started with Teams apps, or just you've heard about Semantic Kernel, welcome. If you're a developer, I will get a little more technical later on. We will look at code. We will see an example that I think is going to be a pretty cool example that's not like examples you're going to get out of the box. So hang around for that. And with that, let's get started. So the first thing we need to figure out with Semantic Kernel is, what is it? On the screen here, you see the Microsoft definition of what it is. As I said a minute ago, it is an SDK that allows you to build agents and integrate with models and things like that. That SDK is available in C#, Python, or Java. So you see the official definition. I'm going to try to give a more folksy definition. So in the graphic on the right, it's a typical environment. You've got code, you've got models, you've got hooks and filters, you've got stuff laying all over the place. What Semantic Kernel does is it essentially creates an orchestration layer on top of everything else in your environment, so that you can allow these different components to interact. So it'll be a single object where you can inject different components from your environment into the kernel, and that allows you to then interact with them via the kernel. And one of the cool things about the kernel, as opposed to something like LangChain, is that there is a single place to go to initiate any of those actions. If you, for example, in other packages, you might have to hunt around to find, what's being operated on now, what's the status of X, Y, Z, and you might have to hunt around for a bit. Where with the kernel, you're just dealing with that singular kernel object. So more with the background definition of Semantic Kernel. So as I mentioned before, you can bring in your existing code as plugins. You can also reference other application endpoints, etc. in your environment. Now, I mentioned, if you saw the previous video about the OpenAI Assistant API, I keep getting that wrong, that I said there would be a lot of overlap with Semantic Kernel. So I'll show you where it's the same, and I'll also show you where it's different. Where it's different is the Semantic Kernel is essentially an umbrella for all the components in your environment. Now, one of those components could be an app or bot that you made that uses the semantic kernel, the OpenAI Assistant endpoint that would be considered in this graphic another AI app. So you could do a lot of the same things with Semantic Kernel that you did with that app, but really the Semantic Kernel is meant to be that orchestration layer that can manage other components, including the OpenAI Assistant app that you might have. So what makes up this Semantic Kernel SDK? Well, there's the kernel itself, which is, again, the main orchestration object. It is a singular object. that can use to inject or query or a variety of things. Memories, another fancy word for history. The kernel can retain the conversation that you're having and also make that available to any plugins you might have. Planner. This is what we're going to see a minute in the demo, and it's going to be similar to the demo that I did in the previous the OpenAI Assistant video, but there are going to be some differences. Now I'm going to show you the difference between the kernel and the OpenAI Assistant plugins. We're going to see that in the demo as well. Again, that's bringing your own code and injecting it into the kernel for potential use. But you might have code or other applications in your environment that you could reference as an endpoint that would be a little bit different. And connectors. It's the bridge to other components, models, databases, etc. A common one, if you've been coding these, is to set up the connection to your OpenAI completion or chat endpoints. Plugins are an optional but often very important aspect of the semantic kernel. When we talk about plugins, there's really two types of plugins. There's the and there's a lot, as I said in the previous video, there's a lot of different interchangeable words. Plugin is usually the general container that holds other functions related to that plugin. And we'll see more of that in a second. So there's really two types of plugins. One is a semantic function, and that's, generally speaking, where you want to modify either the incoming prompt or the response back to the user. So, for example, one that comes in the documentation is a Shakespearean plugin that will translate whatever text you have into something that would sound like Shakespeare wrote it. So that's one. The second one, which we'll be focusing on in the demo, is a native function. So this is where you're looking to do something a little more beyond that. Maybe using code, but maybe not. You can certainly accomplish or create a function with just JSON. But if you wanted a more complex example, you would definitely need code. So an example of that is, you want to call Salesforce to get the status of a request. That would be something that would require code and thus would be a native function. So let's talk a little bit about what I'm going to show you in the demo, how we piece this all together. In the previous video in this series, I created a demo for the Assistance API where I could bring together a bunch of functions and allow, in that case, the model to come up with a plan. So I kind of, I'm going to do a similar thing here, but there's going to be a couple of twists, and I'm going to make it a little more Teams-like, and you'll see that in a moment. So I have 4 functions. Get all lights, get the ID of a light, get the status of a light, set the light state. And you'll notice that some of them have different inputs. So, for example, if I want to set the light state, I need the light ID. To get the light ID, I need to call this with the name to get the ID to then pass to the set light state. So keep that in mind as we go through the demo. So one last slide before we get to the demo. We're going to talk about the planner. So as I mentioned earlier, we're going to focus on the things that are specific to the kernel. I'm not going to get into chat history or RAG or vector databases or things like that, because those are things that kind of, we talked about the kernel being an umbrella. Those are things that could be potential components underneath that umbrella, but I could spend the rest of the day giving demos on those things. So I'm just going to focus on what makes the planner unique, or what makes the kernel unique, and one of the key parts of that is the planner. Again, completely optional. You don't have to use this. You can, once you inject, for example, plugins into a kernel or um, prompt augmentation, you can just use the kernel to interact with those components. Um, you can use the planner. What the planner does is the kernel, if it detects plugins that are useful to satisfy a prompt, the kernel will put together a plan to satisfy that prompt. So, for example, uh, I could tell the kernel turn off all the lights. So if I was going to logic this out, just pseudocode here, using the functions that I showed you in a previous slide, this is probably how I do it. I'd call the get all lights function to get a list of all the lights for each light, and when you see that for each, that means that's a loop, that's code, right? Um, get the light status, and then finally for each light that is off, again a loop, call set light status to turn the light on. So again, just kind of verbalizing how the code might be structured. It would probably look like this if I was putting together a plan. And with that, let's take a look at some cool stuff. So what we're looking at right here is a Python Jupyter notebook. One thing I recommend doing as you're getting going on this, so this is straight from the Microsoft samples repo. I'll put the link in the underneath the video. So these first 11 notebooks are from that. What I'm going to show you is I've created my own example, not using their functions or anything like that. Again, I recommend going through these, learning them yourself. The version of the Semantic Kernel package matters a lot. As of this creation of this video, September 19th, 2024. This will work with this, but if you're following older examples, even 3 or 4 months ago from the internet, the current kernel is probably not going to work. So with that, instantiating the kernel, I'm not going to get too deep into the code here, but I'm going to point out a few things. So as with the Assistant API, it can be used with Azure or just with regular OpenAI. So there's a little selection here. So what I'm doing here is I've created a file, a class called Lights plugin. If you recall, a few minutes ago I mentioned that that there's essentially a plugin container that has individual functions. So I've got my Lights plugin container. I've got a bunch of the 4 functions that I mentioned in the previous slide. You'll see a decorator here to tell the kernel that this is a kernel function. And again, you'll see everything I talked about in the previous slide, the inputs. This is all Python code. And there's get light ID. And you'll see at the bottom some adaptive card code, a little foreshadowing there as to what's to come. So let's continue to step through here. So what I'm doing here, I'm essentially creating an object for each function. Now, there's a couple different ways to do this. You could have also done a kernel .invoke to launch a specific function. So what I've done here is I've created an object and then use that object to call, passing in the kernel and then giving it the inputs that function is looking for. So the result of that is, oops, I forgot to run it. Yeah, you'll just see that they all ran. Not terribly interesting at the moment. I can also, just to give you an example, I can, remember I mentioned that the kernel is essentially a container for services, connections, functions. So what I can do here is I can loop through and see what the kernel is aware of because I injected it. I injected it up above. So moving on. So now we're going to get to the fun part. Let's start doing some stuff. So what I'm going to do is I've got a few pre-staged prompts, and I'm going to explain a little bit of what's different from the previous video where I asked it to turn all lights off. And I'll talk to that in a moment. So at the moment, I'm going to ask it, what is the status of the light, table light 1? Now, if you'll recall, the get status function only takes in an ID, not the string name of it. So what I'm doing here is I'm just going to take a step back. We're creating a planner object first. We're instantiating that, and then from that planner object, I'm going to pass in the ask, the prompt, and the kernel using this planner object is going to come up with a plan to satisfy that prompt. And here is so right now at this point I'm not executing it. I'm just asking it to tell me what the plan is. So as I mentioned a second ago, the first, so it identified, it's smart. So it's how it's doing this is it's using the description. It's using the information that you've given it to identify what are the inputs, what are the capabilities. And then from that, it determines if these functions match what the prompt is asking for. And if so, can it use one or more functions to put together a plan? So that's what's happening here. We want it to turn off table light 1. It recognizes that it needs the ID of that light. So it calls get light ID with this parameter. It then gets the status, and yeah, it returns the status. So there's a little bit more here, which we'll talk about in a moment. So that's the plan. And if I go through and execute that plan now that I've got it created, you'll see that it is off. Let's go through. Let me comment that one out. Let me change this to on. On. Okay, no problems there. So let's do something a little different and outside of what's shown in the documentation. Let me turn it back off. So what I've added here is an instruction, an additional instruction, that I want to see it in an adaptive card. Okay, there's the plan. So let's come down here. You'll notice the addition of the adaptive card in that plan. Okay. So it's turned it off, and it's also created an adaptive card. Now I had it write it out to a file. So let's look at what that file that is created. So I created this, and I've installed the preview adaptive card extension. So let's see what this looks like. Light is off, and you'll notice that you can preview how it's going to look in Teams depending on the theme. Let me close that out. And I could similarly come back in here, and we'll do the same thing again. Alright, you created the plan. Let's invoke that plan. Adaptive card, so it's turned it on. So underneath the covers, this is a Hubitat home assistant that I use to control my home automations. And then if I preview this card, different experience for the user. So again, it's an adaptive card. You can craft these to your heart's content. There's a lot of cool things you can do with that. So one thing that I discovered while doing this, and you may have noticed if you watched the previous video, is that I did not, just get rid of these, I did not ask it to turn off all lights. And the reason I didn't is because it doesn't work the same using the planner. So, as you may recall, when I called this using the Assistant API, the Assistant API was smart enough to, for example, when I said get all lights in the family room, to return all of the lights in an array, which the planner will actually do as well. But the difference is that the Assistant was smart enough to then call the set light state function one at a time, passing in each light. Whereas I think with the planner that these functions were meant to be called inline. You're not the planner won't put a wrapper for each around that in this case. So that is one difference here where I couldn't use the functions as I originally coded them. Now I could have recoded them to to take inputs of arrays, and made it a little more flexible. But I do want to kind of call out the difference between this planner, the actual planner object, and the plan that an Assistant API might put together under the covers. So that is all for today on my talk on the semantic kernel. I'll put a link to the repository, the Microsoft repository. I'm not going to put a link to my specific functions because they are very specific to the Hubitat API. But there really shouldn't be anything controversial. You should be able to recreate the same things if you need to. So thanks for watching, and if you like, please subscribe. Thank you.